the intro, and it's time to go over to our first speaker of the day. Paul, are you here?
I am. Thank you very much, Joel, for inviting me to speak, and the team as well, who've been really helpful to me, and everybody I think who is speaking has done a lot of help from you guys. And thank you for letting me talk about this topic, because I think it's quite important, because everyone seems to have this on their agenda, but when you talk to people who are looking to either acquire machine learning and artificial intelligence capabilities, or are selling it as part of their tool set, it's the landscape is very fragmented, and there's no kind of vision, if you like, coming from the industry to say what ML and AI should actually be doing for us. So I thought, okay, well, I'm going to take this on as a challenge, and I'm hoping that what I'm going to try and do is give you a kind of a foundation where you can look at what is on offer from the vendors in terms of, and I'm going to talk mostly about modeling and test execution, okay? But when you talk to the vendors who are offering these fantastic tools and new offerings, you have a foundation that you can say, well, I can visualize where that fits into my the way I think in particular, and the way I build and implement and understand my testing. So let's go, and let me make a start. So this is a longer talk, I have to say. So, and I think it's not really very helpful to spend too much time on machine learning and artificial intelligence, because everyone's had a look at it now, and you've probably got a view, and probably got a very confused view, because the definitions of these terms kind of vary with where you look. So I'm going to give you a definition, a working definition, which is probably wrong, but it helps me understand and me to explain what I'm talking about. So, okay, so I'll spend a moment on ML and AI. Now, because machine learning, artificial intelligence is in principle doing something that our brains would decide to do, you know, we're really trying to take a part of our brain and replace it with some software, if you like, and some data, okay? We have to understand how we think to understand how machine learning and artificial intelligence fit into our thought process. And this is the way I'm going to present some ideas as how we align our thinking with how vendors are going to market their new products. So some years ago, I put together a thing I call a new model for testing. And okay, you could say it's not new, but okay, maybe it's marketing, but I still call it a new model because it's the only model, I think, which tries to explain and diagram how our brains work when we are doing the job we call testing. So I'm going to not spend any time on that, but I'm just going to present it as an image and then just talk over it for a couple of minutes and then move quickly on. I'm going to suggest that the tools we have at the moment, mostly the ones that don't have AI and machine learning, if you set that aside, test automation tools, test execution automation tools are mechanical tools. And what I mean by that is they don't help us to think. They do a logistical task, which is great and helpful, but these do not help us to think, and they're not relevant. The mechanical, automation, if you like, is not relevant to where we apply machine learning and artificial intelligence. Okay, so I'm going to sort of try and set that aside as I don't need to worry about that stuff. So I think another thing that is relevant is, and it's kind of occurred to me just a few months ago, that I don't think we understand integration well enough in the context of our process, which is very dynamic now. If we're moving towards continuous integration, continuous delivery, continuous understanding of our software requirements and our software delivery. So all this idea of continuous shift left, shift right, monitoring production, using AI to make decisions on requirements, all this stuff is really moving quickly, and testing isn't moving at the same pace. We are being left behind. So we have to think a bit more carefully about how all software testing, again, this is a proposal I've got, at all software testing at one level or another involves integration and is delivering an integrated component, subsystem, complete system, or a system into a production environment. So we've got this idea of integration, which is important. I think we need to understand and be very clear about what we're trying to do there. And also this concept of test realism. So every tester knows that, you know, when we're trying to demonstrate whether software works for users, we'll use realistic test data, realistic scenarios, realistic user journeys. But obviously developers who can't see the user interface, perhaps if they're working on services, have to use artificial data perhaps. But this concept of synthetic or artificial data and realistic data is part of what we need to understand when we're looking at machine learning and AI. Okay. So with all that background, and then I want to sort of make a statement and a kind of give you a vision, if you like, for what I want to see personally, what I want to see from the tool vendors in the future. And I'm not going to spend a lot of time on that because it's not that complicated, I have to say. All the complication is understanding how machine learning and AI fits into our brain patterns. Okay, that's the complex part of this. And then the tool vendors have to do their complex development, of course. But the challenge we have as testers is to fit machine learning and AI into the way we think and the way we deliver our service of testing. So, okay, very quickly, I'm going to talk about ML and AI, and I'm just going to give you two definitions. And I say crash helmet on because some of you will say, no, that's not right. That's not academically correct, or wait a minute, there's another way of looking at it. I get all that. But what I'm going to do is give you a very simplistic view of machine learning and AI. And I'm going to say this, that ultimately machine learning and AI depends on models and data. Okay, that's the basis of machine learning, is data. And what the machine learning kind of process does is develop, let's say, through some very sophisticated techniques, models of that data which help us to make decisions. Now, some of those decisions can be made by machine learning, and some of them require artificial intelligence to make more informed decisions and better choices. So what I'm going to suggest is this, that machine learning is basically tools, software agents that offer suggestions to us, that help us to make progress. They do research, let's say. And artificial intelligence, AI, are software agents that make choices for us if we choose to let them make choices, okay? So we have control over AI. We don't have to let AI take over, but we could, okay? So with that background, a question that arises usually is, well, will testers be replaced by robots, you know, however they are built? And I would say no. I think where we want to be is that we need tools that offer suggestions and make choices if we want them to. And right here, right now, the human part of software test design at the moment is very poorly supported by technology. And again, there'll be people out there in the audience listening to this now will say, well, hold on, we're using this tool or that tool, which helps us do this. Yes, and we're on that journey, but I think we're still rather early in that journey. A couple of references for you. I won't talk about them other than to say that I wrote some papers some years ago, and I don't think they're so far out of date, but because the first one was about using test analytics data to make decisions, and we're still early on that journey. And the second one was about, well, will tools be replacing testers in the future? And again, I defend my answer that no, or certainly not yet. And that's the second paper. But that's the basis of some of the things I'll talk about. But I've moved on quite a way since then, but that's some background. So I want to talk about how we think as testers. And if you like, what we're trying to do with machine learning and AI is supplement our thinking. So we want tools to substitute for parts of our brains that spend a lot of time creating models, analyzing models, deriving test data, structuring tests, executing tests, analyzing the outcome of tests, and then making a choice or a decision on what we do next. And these are the things that we think about as testers. And so I'm not going to offer a process, that has a start, a middle, and an end with inputs and outputs and a procedure and entry and exit criteria, all that kind of stuff. No, that's all kind of logistics. What I'm talking about is how we think as testers. Now, I want to sort of spend a couple of minutes talking about some models that you already know and love, or hate, maybe, I don't know. And the first one is a very familiar one, I hope, which is this Lisa Crispin's, Janet Gregory's 4-quadrant model, based on Brian Marrick's ideas a few years earlier. And this is kind of helpful, but I want to suggest that it only gets you so far. It's a kind of, yeah, okay, well, that gets me to day 2 of my test strategy. It doesn't tell me how to implement that strategy in any way. It doesn't offer much more than that. It's a very, very high level framework, and it has value, but I'm not sure it has the value that I want. It certainly doesn't help me understand machine learning and AI, and that's kind of its drawback. Now, if you go on the internet and look for the, I search for Brian Marrick testing quadrants, I mean, there are dozens of examples, and every consultant has their own flavor of the same kind of model, and that's fine. But this has been around for some years, 10 or 12 years now, I can't remember exactly. And the thing is, like, we haven't really moved on very much. Now, the other model that gets a lot of mention is clearly the automation pyramid, because machine learning and AI, we assume these are going to help us do better automation, or rather take advantage of automation in ways that we can't do without machine learning and AI. So the automation pyramid, again, I think is useful, but not very useful. It tells us something, but it doesn't tell us an awful lot. And you can, say, well, okay, well, it's kind of a common sense, a proposal for how you think about the quantity of testing you do at each stage. And it encourages us to think that manual testing is something that should be in the minority and so on. And it says some things, of course. But you know what? If you map that to the good old V model, it maps perfectly to the V model. And the V model has been around since the 1980s. Our thinking in this area hasn't moved on in 30 years. And I mean, I'm sorry, that's not good enough for this industry, because the industry is moving much faster than it ever did. And we left the V model behind about 15 years ago, maybe longer, when Agile made its appearance. And don't get me wrong, the V model itself has value if you're working in a structured waterfall environment. But most people have moved on from that, or they're using a hybrid kind of model between structured waterfall, Agile, and maybe even doing some continuous delivery concepts and DevOps and that kind of game. So, I'm disappointed that no one has come up with a better pyramid model and a better 4-quadrant model. And because we need these things now to understand machine learning and AI. And of course, if you do a search for the test automation pyramid, there are hundreds of examples on the internet. Every consultant has got their own version saying pretty much the same thing. So are these models useful and still relevant? I think yes, but I'm sorry, they're testing 101. They're too basic. That's the first day, the first day of your foundation course in software testing. It doesn't get you very far. That's the problem I have. And we kind of praise these models and people sell them as a really sophisticated approach, and they're just not sophisticated. We've moved on. The world has moved faster. So we need to think more carefully about how we think and try and set aside what I would call logistics. And by logistics, what I mean are things like, do I care whether we document our tests, or we do all our testing as exploratory tests, or we run tests as automated scripts? I don't care, because that's a logistical choice. Now, the process of exploration is something that maybe a human has to do, and the tools implement automated scripts, for sure. But the choice of that choice is a logistical choice. I don't care whether I'm working as an individual or a team of 100 testers. I don't care whether I'm Agile or waterfall or I'm in a continuous delivery environment. That's a logistical choice. It doesn't change the way I think about how I test. And so what I came up with some years ago with this model, which sets out 10 thinking activities. Now, this isn't a process with a start, a middle, and an end. It's a model of the different modes of thinking, the different states of our thinking, as we proceed from sources of knowledge on the left through to running tests and interpreting them on the right. Now, I'm going to talk about this for about a minute, and then I'll have to move on because this isn't the subject of the talk, but there's a link there you could follow. There are quite a few videos. There's half a dozen videos of me talking about this stuff. So please follow that up if you want to know more. But on the left, we have this concept of sources of knowledge. Now, a source of knowledge could be a requirements document or a user story or a cucumber story in the gherkin kind of format, or it could be a human being who tells me what they want from software. It could be the old system tells me what the new system should do in some way. And the new system, when it's available, is a source of knowledge. Now, on top of that, as a tester, I've got my own experience and my own knowledge and my own prejudices and my own biases, which all complicate everything I learn from my source of knowledge. It is a source of knowledge in its own right. So what the skill of testing is to try and understand from the perspective of our sources of knowledge what our system should do. And we build mental models in order to understand what we do. And if you like, the models in the center at the heart of testing, I would say, these mental models may be written down, but that's a logistical choice. I don't care whether you write them down or not. Okay, these models exist, whether you write them down or not. We use those models to inform our tests. And when we apply our tests, we run them, we execute them. I use the word apply because I don't care whether you use humans or tools to run those tests. So I'm using the word apply, okay? There's an interpretation aspect and so on. Okay, so I'm not going to talk any more about this model really, but I just want to suggest that these are the 10 ways of thinking that are involved in doing the job we call testing. So I want to suggest that when we use this term, test automation, there's quite an argument about whether it's misleading and we should ban it, from conference talks and books and blogs and whatever. It does mislead because people think, some people think test automation means the complete automation, everything in test. And right now, it doesn't. It only applies to what we normally would call execution, whether that's by a tool or a human being. And the applying activity, thinking activity, sits on the right-hand side. It's one activity of 10. Tools implement this applying activity, thinking activity. Call it checking if you want. I think there's a pretty direct mapping from the word checking and the way checking is used in the industry nowadays to what I call applying. I could put checking on the model and call it that, but I think it has other connotations. And so I use the word applying. So it only does one activity out of 10. And that's how I explain how tools do not meet the tools do not automatically allow you to reduce the size of your testing because all the thinking on the left still has to happen. So I want to just walk through, if you like, how this model fits in the context of how we build software is if you like, the thinking on the left contributes to the definition of a feature or the construction of a requirement, let's call it that. On the left, this is our opportunity as testers to challenge, to test our requirements, okay? Whether those requirements are narrative text or user stories or formal models, whatever they happen to be, okay? And on the right-hand side, we use those models once we've got them right, if you like, once we've challenged them and fixed them, repaired them and refined them. The models in the center are, if you like, the blueprints. They're what we use to inform our test design. Now, the model might be something as mundane as a flowchart. Well, we can use a flowchart to trace paths, to pick off conditions to exercise, and so on. And there are many models that you will be aware of from any test design course or class. So the models are the basis, the blueprint, if you like, for the tests on the right, whether we automate them or we use humans to implement them. Now, if you don't have a good understanding of a model to define your paths of testing, that your test cases, if I can say that, automation won't work if you haven't done the thinking on the left. Because firstly, you'll have probably a different model to the developers, because you haven't challenged requirements and shared with the developers what you think might be at fault. But also you won't be synchronized with the rest of the project. And it's really important that we identify these schisms of understanding early so that our testing, whether it's automated or not, is going to be sound. So if we apply automation to poor requirements, where the developers are going to be building crappy software and our automation is just not going to work at all. It's going to be a disaster. Okay. If we aren't involved on the left, if we don't do the thinking on the left, we're not in a good position to test whether we're using tools or not. Okay. So that's kind of the vision for how we think, right? So let's set that aside. I want to talk about tools that we have today. And I want to suggest that the current tools we have, I would say, are mechanical tools. They execute logistical tasks. They collect data. They run transactions. They do comparisons with expected results and the actuality. They give us some statistical analysis of passes and fails and so on. And that's great. And we'll always need that, but we kind of have that now. Okay, that's not what we need. What we really need are the thinking tools which help us to build meaningful models of a requirement and the behavior of our systems, and a mechanism for using those models to generate test ideas, test cases, if you like. So the thinking activities in the new model, I think, are very poorly supported, and it's quite clear where the current tools fit. They do some logistical stuff to do with executing tests, and that's it. What I call applying. They don't give us a lot of support that we need. Now, okay, so what's the best thing we could do with tools? Well, right now, integrating our test design, test management tools with test automation, that's easy, because these are logistical things, and we can have a consistent schema for our test cases and our test automation. And we can have test automation frameworks. This is kind of what every company does. They build their own framework in many respects. This is kind of easy. It's a purely logistical problem. Now, of course, what would be really nice would be to have better record keeping of our tests and our analysis of tests with respect to coverage, whether it's planned or executed and achieved. Okay, so I mean, there's more to record keeping than that, but record keeping is about having, keeping good records of our test design and execution activities. And again, that's easier. It's not the easiest, but it's not so hard. Okay. The hard thing we need to do is to support human thinking and collaboration. And my warning to all you out there as testers is the vendors will stick with the easiest problem rather than the most useful solution. So we need to encourage our vendors to think about how we think about testing and fit their wonderful tools into our thought process, not just do the logistical thing. So the way I look at tools and this is a kind of a little distraction, but it might help. I think of tools in two dimensions, if you like. I'm going to come up with my own 4-quadrant model. It's not about test process. It's about the tools market, the vendor kind of marketplace, if you like. And the two dimensions are these. One is the ability to capture knowledge, which is essentially record keeping. And the other dimension I'm going to suggest is the ability to investigate, to explore. And the second dimension, this ability to investigate, is, if you like, the hard one. Okay, now you could carve up tool capabilities in 100 ways. Okay, I'm not saying this is the only way, but I think this is helpful in understanding where we're at with tools capability. Okay, and essentially where we are is we have made some progress about record keeping and model making and test case generation, whatever. And some tools are more advanced than others. So this, I'm not suggesting this is very speculative, but we've made very little progress in terms of support for testers exploring their sources of knowledge, whether it's the old system, the new system, requirements, and so on. Again, there are some pockets of functionality available in some tools, but essentially we haven't really replaced any of the thinking that testers need to do. And now that there's some progress on the way, but right now we're starting at a very low level. So I just need a drink. I'm sorry, my throat is a bit, my throat's a bit hoarse, I think, today for some reason. So in terms of ability to capture knowledge, we've made progress because we can use a text editor, we can capture screenshots, we've got record, replay tools, that kind of stuff. But pencil and paper, because of its flexibility, is still what most people use, you know, and that sets us apart from most other technologists who have tools to support what they do. Most testers spend a lot of their time using Excel spreadsheets and pencil and paper, notebooks for note taking. You know, we don't have great progress yet. There are model making facilities which are available across the industry. We need to make more use of these, but we need them integrated into our test process, our thinking process in particular. The other dimension is about our ability to investigate. And if you like, pretty much the tester has to do all the thinking and has complete control over the exploration process. And I strongly suggest that all testing is exploratory. We might explore the system under test, but when we explore requirements, looking for opportunities to test, when we explore the old system, looking for opportunities, when we interview users, asking them what they want and what they're concerned about, this is exploration of the sources of knowledge. And our source of knowledge isn't just the system under test, okay? Now, it could be that at some point, the tool will do all the thinking above. It'll interview users, it'll read requirements, it'll scan our system under test and come up with ideas for testing. And there are some utilities that make some progress in various areas here, but we don't have an integrated tool set is the problem. And this is where machine learning and AI needs to help us, okay? So I would suggest that the vendor challenge is not test execution, you know? So, you know, I'm sure we've all heard of Selenium and so on, and other open source tools that can help us to test software. Test execution engines are commodities, okay? The money, the commercial offering has to be in something at a higher level in terms of capturing models as the basis of our testing, test design and selection, test data management, exploration or survey support, as I might call it, and frameworks as well, needless to say. And this is where machine learning and AI has to help us. So, okay, so that's kind of the vision for where the tools need to sit in our thinking, because they need to help us to do some serious, complicated thinking. But I want to talk about integration and test realism for a moment, because I think that's also relevant. It's another driver for where we're going to be looking at machine learning and AI. So let me first say that I think integration is often misunderstood, and the number of times that software which we believe works in one context, say in a developer's environment, suddenly when we move it into an integration environment, it doesn't work, or it has difficulties. We have difficulties of consistency and communication and synchronization with other components, with other subsystems and so on. And integration is like a problem in every organization who builds software, because integration problems reflect communication problems between users, technologists, testers, operations, technical architects. You know, integration is a communication problem, okay? So if you like, if you step back and say, well, we can solve this by having a link, a component integration test activity, and we can have a system to system integration activity. Well, you know what? I think integration starts when you write the second line of code, because the first line of code and the second line of code have to be integrated. And when you bring a component into a subsystem, sure, that has to be integrated, and subsystems to complete systems, and systems to other systems. A system of systems needs integration, but also the system we deliver into production has to integrate with our business processes and the people who use it. Integration is all pervasive. And that has to be part of our thinking of how we understand the testing challenge, that integration is all pervasive and it's absolutely inevitable. You can't escape it because we can't build systems in a big lump. We have to build them from components step by step, and we have to match them to our user requirements and our business processes and context. So, one of the reasons that we have had a problem with integration is we have this concept of integration from the perspective of developers who see the software system as, the system under test, the scope of the system under test. But our users don't think that way. They look at that system in the context of a business, talking to many other systems, and it's a much bigger scope. And so there's a perspective difference, which has kind of got in the way of understanding integration in a better way. So I don't want to dwell on that because it's kind of, we've always known this, that the techies and our businesses don't communicate well enough. It's part of that kind of problem. But I want to share another kind of, if you like, dimension of this. Is one way of looking at this would be integration as a vertical integration. That is between the presentation layer, the user interface, working down business services, enterprise software, and then looking at a database at the bottom of the stack, if you like. And that might be vertical integration. Okay, I'm going to move on quickly. Horizontal integration would be where you're looking at the surface, okay, of the system under test, because that's where users get involved through the user interface. So you might call that horizontal integration, and that might be helpful. It might be a bit simplistic, but I'm going to use these terms, vertical and horizontal, in a couple of minutes. And so what I'm going to do is offer you a model, which is a 4-quadrant model, like every other one. And these are the axes. On the left, I've got, if you like, what I'm going to call vertical integration. That is a technically oriented view of integration. And on the right, I've got systems in context, if you like, a horizontal integration. I also call this, depending on who I talk to, enterprise business process assurance. If you're dealing with very large systems, all the hard work is on the right. Okay. Anyway, the other dimension is I'm going to use the word validation, which is an old-fashioned term, but I think is perfectly valid, and I think it's a valuable way of looking at things now. Validation, build the right system. Okay, that's how it was typically defined. And verification, a more technical view, build the system right, build to spec. The developers, the technologists have said this works for me, if you like. But validation says, well, does it work for the end user? Does it give them what they need in their context? So these are the 4, if you like, axes, or 2 axes defined. But I'm going to qualify these by adding some more information on. On the left, I think we can talk about system flows and transactions that are synthetic. And on the right, we have business flows and user journeys that are real or more realistic. At the top, we have more realistic data, maybe copies of live data in some examples. And at the bottom, we have verification, which tends to say, does the code do what I think the code should do? I don't need user data for that. I just need some example, some synthetic data. So if you look at these dimensions, we can then put in the 4 core test and integration test kind of activities. Top left is component level. Bottom left is component integration, subsystem integration. Bottom right is system to system integration, and top right is business integration, where we integrate our system of systems with our businesses. Okay, and we can also label these with if you like, a graphic which might suggest how much automation and how much manual testing is involved in these activities. And so what I want to suggest is we've made progress with component testing and component integration testing, but we've made much less progress with system to system integration and system to business integration, or user integration, you might say. So I want to suggest that these dimensions of realism, if you like, again, are part of what we need our artificial intelligence, machine learning to accommodate, if you like. We need to have an understanding of where our tools fit, because it's no good having a tool that only does component integration. It's not going to help with anything else. So we need tools that have this realistic data and transaction and business flows, if you like, has that at its heart. So enough of this. I just want to suggest that realism kind of starts bottom left and it's at its height top right. So let's move on. So I've only got a few minutes, but I think what I have to say is fairly straightforward now, and it's a vision, if you like, more than anything else. We all know about structured waterfall stage testing versus exploratory testing, and there are proponents of both sides that say structured testing has value because it's systematic, documented, and so on. Exploratory is more agile, improvisational, more imagination is used, and so on and so forth. All true, all true. But there are downsides. There are bad things about structured stage testing. It's expensive, boring, it can be inefficient. And exploratory is often not repeatable because it's not captured in any meaningful way. It's not easily automated. There's not usually a lot of documentation comes with it if that's how you want to operate, and so on. Okay. So what I want to suggest is, well, certainly whoever you talk to, different people have different perceptions of what is good and bad about each style. But here's the pitch. I think we need the best of structured and exploratory to make progress. For example, if we don't use the imagination of our testers to explore the content of our sources of knowledge, our requirements, our systems under test, we're not going to get the best models. If we don't use the structure and the record keeping of, if you like, a staged, waterfall, structured approach, we're not going to have the data for our machine learning tools to operate on. You need both. In terms of exploration support, I want to suggest that maybe we move to a surveying metaphor. And if you like, when a tester explores the system, what they discover could go into a notebook, sure, but that can't be analyzed by any tools that we're ever going to get. We need that data to be captured in real time by, let's call it a capture tool, okay, a mechanism to tell us and build our models that we can use for navigation and testing. So I hope the next generation tools will support the exploration of our sources of knowledge, okay? Now I want to suggest that I call it exploration, and that might be the best term, but it's a bit, as a professional engineer, let's say, surveying is a much better understood mechanism. And so if you like, what we do as testers, we survey the system to map the territory. And when we trace paths and we do our exploration, I want a tool to record those paths and behind the scenes build a model from those paths. And that's perfectly possible, okay? As you explore more and more, the system model emerges. As multiple testers explore the same areas of the system, our tools know where previous testers have been and explored and will tell us where there are uncertainties in the model. The paths we capture could be the basis of automated tests, but because we have an underlying model, tools can generate combinations and permutations of paths, which may be of interest to us. And the tools can, the information required for scripting is all part of the model. And if we have a model in a digital format, tools can generate paths and test cases, can generate test data values for input, but also identify data if we have a model of our system under test can also identify sources of data from our databases and perhaps our production data. And that's where we need machine learning and AI to help us out, because these are very difficult, complicated logistical things, but we cannot get meaningful outcomes from tools scanning production data without those tools having a knowledge of the paths of execution, a knowledge of the behavior of our systems under test, through tests, and an understanding of the previous defects that have been found and location of them. Because we need to, influence our tools to make better selections, like testers do, but testers do it from experience. And if that experience is not available to our tools, we will never have tools that are as good as our testers. So we need a scalable, automatable process. And if you like, my vision is humans make the early maps with tool support, and then tools will follow the trails we map, okay? That's the general idea. So if you like, what I want to see is a tool that looks something like a developer's integrated test environment. So I'm going to integrated development environment, I beg your pardon. What I want for testers is an integrated or interactive test environment. So perhaps we have like a survey mode where we navigate through our system under test. We have test ideas as we go. These are all captured in a model, and that model can then be edited to, if you like, tidy it up, okay? So we know our exploration might not always go well. So we need a kind of an edit mode to edit our model, okay? And add, if you like, elements to it to refine it and make it more comprehensive. We need an interactive test mode where we can run a test step by step, like a developer working through code, line by line. It's a bit like a debugger. So we need an interactive test or an interactive test debug mode. This is what we need to make sure our tests, if you like, stand up to scrutiny. And then we need an unattended test mode, which takes our debugged tests and runs them. And we need these 4 features for all time as our systems evolve over time. So, okay, so that's the vision about what's there. Now, wait a minute. Okay, to what degree can we trust tools to test everything? Well, we have to consider, checks that can be automated by developers. That's part and parcel of it. Checks that can be automated by system testers or through service calls. Then there's the kind of compatibility checks across platforms. These can all be automated and should be automated. But then there's a small subset that can only be performed by a human. But I want those tests to be picked up by our machine learning and AI technologies that base their decision making and choices on data held in a model that is built by our testers who have done the basic survey cum exploration. We have to let go of late manual checking, because this is the one thing that we can't escape in some ways without tool support. We can trust to tools, but there's always the concern that the tools do not have any imagination. So I think it's the wrong question to say, should we support tools doing all the testing? What we need to do is we need to think differently about how we explore the territory, how we build our models. We need to use tools to do everything. That is, when we run a test, we don't connect directly with the system on a test. We operate through a tool which acts as a proxy, which captures the inputs and captures the outputs as a permanent record as the basis of a model. And we need to be able to let tests run unattended, of course, as always. So this is a different challenge than the usual thinking that goes with tools in this area. So I want to say one final thing. I think it's a great opportunity for testers to firstly influence the tool vendors and ask them sensible questions about what we really, really need. We need stuff from the vendors. We don't want the stuff that vendors find easy to build. At the moment, they are still picking low-hanging fruit. We need tools that support the capture of requirements, the challenge and refinement of those requirements, whether they're stories, typically stories. We need to capture surveys or exploration outcome and build a system model. We need tools that will help us and lead us to better exploration activities because the tools have the model in their brain, if you like. Okay. I want an integrated, interactive test environment, and I want tools that offer suggestions and make choices under our control. And that's really the goal. Is what we want are not tools that do everything we do as testers. We need tools that support the things that are difficult, not the things that are easy, like test execution automation. That's an easy thing to build. I'm done. I think I've overrun. I'm so sorry, but I think I got through everything I wanted to say. And if there's questions, I'm very happy to take them. I'm guessing through, is it going to come through Slack, Joel? Is that the idea?
Actually, there are some questions that people are already asking here. And because we're obviously not going to have time to go over everything, we have about, I can go over 1 or 2 questions, and then we need to take a break. But then I think that people can just go ahead and go over to Slack. But let's go over, again, at least 1 or 2 questions that are here that might be relatively quick to answer, because there are many questions that are longer, I think.
There's a lot, yeah.
Yeah, so there's a question here that is, are there any tools already doing that or starting to do stuff similar to that?
I think there are, I'm not going to name names. I mean, I think there are vendors who are making progress in this area. I think there's a lot of work being done that is not publicly visible yet. So I've no doubt that bigger vendors have got big teams working on interesting stuff. So I'm not going to give you an answer because I don't think I can give you an answer that's fair to the vendors, if that makes sense. I'm going to be fair to the vendors. Maybe that's a bad thing, but I think the answer is yes. But I think now is our opportunity as testers to start telling our vendors what we need. Because if we don't tell our vendors what we need, we'll get what they think is easy to build. And at the moment, they're using machine learning and AI to do things that I think are not very useful. There's some really good work going on in the package software industry, in particular, like SAP and banking packages, where machine learning and AI is being used to, for example, analyze defect reports so that we can have tool support for getting better defect reports from our testers. So where the pattern of failure is recognized by tools, they can say, well, actually, this could be a SEV 3 or a SEV 5 or a SEV 1 because I've seen this pattern before. And stuff like that's happening. In terms of model making and model-driven testing, at the moment, models are kind of constructed separate from the exploration process. So, you know, I mean, there are tools, I'm sure you know, Joel, where you can build a model of the user interface and use that, if you like, as a either as a flow chart or as a state transition diagram, and let the tools scan those diagrams to generate ideas for test, test cases or test scenarios, if you like. And there are progress, but they're not integrated with our thinking. You know, it's like the tester does some exploration, then they build the model, then they generate some tests. Well, I'm sorry, I want to, as soon as I've done my first path through a screen, I want the tool to have recognized what's there and to have a partial model built. So every time I explore anything in the system and a test, the tool will capture it. And if I'm going over the same ground, I want the tool to tell me you're wasting your time because you're doing something John Smith or Mary did yesterday. That's what I want.
And it's an interesting path. And again, I can speak now with a separate hat, and that is as the evil tool maker, because one of my jobs is basically to be the architect of practice test. And what you're saying, it's a very interesting path that kind of encapsulate a vision where you instrument enough of the system without affecting it, and then you're able to learn from both what the tester is doing as well as integrate stuff that is happening live, because you obviously, if you're working on DevOps, you already have information going on. And it's very, very extremely interesting on a personal basis. And I really liked it that you were able to frame it in a way that makes sense. And it makes sense also to help other people understand what you're talking about. So I appreciate it.
Very positive feedback.
I really appreciate it. In any case, we are running late, and I started late, but you also whereas you're very interested, and I didn't want to stop you in the middle, but we need to take a break. We need to take at least a 5-minute break so that people can go to the bathroom before our next session. So, Paul, it was great listening to you, and I appreciate your insights very, very well, and taking, again, the time to be with us here on the OTC. I apologize that we cannot go over more questions, but I invite everyone to just post them on Slack. Hopefully, Paul will have some time to refer to them later on. So thank you very much for your talk, Paul. It was actually pretty interesting.
Thank you. My pleasure.